Hello everyone, welcome to the physics lesson, and today we are going to study about chapter 1 with the topic measurement. Let's see. In this chapter we are going to study 4 subtopics. The first is what is physics, the second one is the physical quantities and SI units, the third is the measurement of length, and then the fourth is the measurement of time. What is physics? So at the end of this section, you should be able to explain the meaning of physics, explain how the laws of physics are verified. Definition and domain. Physics is the study of matter and energy and the interaction between the two. So remember, the key is in the words of matter and then also energy. So the domain of physics ranges from something as large as the entire universe and planets to something as small as an atom and its constituents. So as we can see, physics is very wide because we are actually talking about the entire universe and the planets. And also, not only that, we can also talk about something as small as an atom, the smallest one, and its constituents. Okay. And then if we see, just now we talk about there is a matter and energy. And in this example, when we talk about matter, matter can be studied from its properties and with the relationship with energy. Okay, meanwhile, also the energy can be studied in terms of its relationship with matters. We can see that there are 4, the general physics, thermal physics, light, waves, and sound, and also electricity and magnetism. And now we are going to talk about the great physicists. And today we are going to talk about 4 great physicists who have made the world of physics different. And of course, by their contribution has made the human lives different. The first is Galileo Galilei, known as the father of modern physics, who have made valuable contributions to astronomy. The next one is René Descartes, who have founded geometry, the study of angles, which we are using especially in the mathematical concept, also in physics. The next one is Sir Isaac Newton, known as the father of classical mechanics. He discovered the laws of motion and gravity. The next one is, of course, I believe all of us have known because it is very popular, is Albert Einstein, who have made many discoveries. And he even won a Nobel Prize for his explanation of the photoelectric effect. But of course, he is the most famous in his theory of relativity. Okay. Now, the next one, we are going to study physical quantities and SI units, which will be, what is that? Will be tested, of course, in your next test. Okay, we'll see physical quantities and SI units. Okay, by the end of this subsection, you will understand about how to show understanding that all physical quantities consist of numerical magnitude and a unit. And also you can list the 7 base quantities and their SI units. Use prefixes and symbols to indicate very large or very small SI quantities. Let's continue. Before we start, we have to recall some of these things. The first, we have 5 apples, 10 kilogram of apples, 5 centimeter cubic, okay, cubic centimeters of water displaced when some apples are submerged in water. So what can we see from this example? We see apples, kilogram, and also cubic centimeters. So what do the different quantities and units tell us? Actually is physical quantity. Let's see. A physical quantity is a quantity that can be measured, and also it consists of a numerical magnitude and a unit. So from the previous examples, you see that we have 5 apples, or 5 kilogram, or 10 centimeter. Let's see and discuss. Examples, if we have 5 kilogram, so which one is the numerical magnitude? Okay, that's good. It's 5. 5 is the numerical magnitude. What about the unit? Which one is the unit? Yes, good job. So kilogram is the unit. Let's see another example. 10 centimeter. Which one is the numerical magnitude? Yes, that's good. It's 10. So the unit is centimeter. Okay, next. SI units. An SI unit is a unit of measurement in the international systems of units. SI is short of System International in French, which means International System in English. The aim of this system is to promote common understanding among scientists and merchants around the world. So we see whenever we talk about the units, wherever we are, even though we are in China, in England, in Singapore, in Malaysia, in any other countries of the world, when we state the units of an object, then everybody will understand how much or the quantity of each object that we are talking about. Okay, now let's talk about the base quantities or units. The base quantities are a set of independent physical quantities. All other physical quantities will be derived by the multiplication or division of two or more base quantities. So, I know you are confused, right? Don't be confused first. Let's listen. The SI units of the base quantities are called the base units. So let's see what it is. These are the base quantity. Okay, if just now we are, for example, talking about apple and the others, we cannot make it as an SI units. You know why? Because the name even for apple, it is not, what is that? It is not common in every countries. They will call it in different names. But when we are talking about the base quantities and the units, and wherever we are and whenever we talk about it, for example, the meter, then people know that we are talking about the length. Okay, and then the symbol for SI unit is meter. So even if we are talking in Chinese or Mandarin, we are gonna use the word meter. Okay, so whenever we are, wherever we are, we can still have the same understanding of the units. About the mass, we are talking about the weight, right? So we are talking about the mass. And then the SI unit will be the kilogram. And then the symbol will be kilogram. Okay, what about the time? We are talking about time in second, not in minute, not in hour, but in second. So we are going to use the symbol S. Electric current. The SI unit is ampere. And then the symbol is capital A. And then for the thermodynamic temperature. So be careful everyone, we are not using Celsius. We are instead talking about Kelvin. Okay, and then the symbol for SI unit is capital K. And about the luminous intensity, we are using the SI unit of candela with the symbol of CT. And about the amount of substance, we are using the SI unit of mole. Okay, and then the symbol for SI unit is mole. Okay, now let's continue. Okay, however, you can see that, please note that the candela is not mentioned in the syllabus. Quantities. A derived quantity is given by the multiplication or division of two or more base quantities. The unit of a derived quantity is given by the similar multiplication or division of the corresponding base units. See the examples of derived quantities. Example 1. If we want to count the area, so we have to multiply two lengths. So we can say that area is a derived quantity. The SI unit of area is meter times meter or equals to the square meters. So for the example 2, when we count speed, speed is counted or measured by dividing the distance traveled to the time taken. So we can say that speed is a derived quantity and the SI unit is meter divided by second or meter per second. See the next example of multiples and submultiples. The magnitudes of physical quantities can range from very big to very small. For example, the width of a hair is between 0.00002 meter and 0.002 meter, but also can be very big. Okay, the mass of a large truck can be 5 million grams. When we write many zeros, A, first it is inconvenient. The second will carries a greater risk of miscounting the number of zeros. Let's say we are talking about 5 million grams. And then because we have to count it or see it faster, so we miss 10. That means it becomes 500,000 instead of 5 million. And that will give you a wrong calculation for the result. So prefixes are used to denote multiples or submultiples of an SI unit. Common prefixes is such. When we write the multiples of 10 powered by 9, so we can use the prefix giga. So the symbol is capital G. If we are talking about the multiples of 6, the power of 6, we can use mega with the symbol of capital M. And then for cubic, we call it kilo. We can use K, small k. And then powered by -1, deci, -2, centi, -3, milli, -6, micro, and -9, nano. Okay, you can also see the symbol. So when you find the symbol, you are able to know how to read it. Okay, milligram, for example, decigram, centigram, and also micro, nano, and so on. What about the use of prefixes? Examples, let's see how to express this in the appropriate prefixes. When we have 5,000 gram, we can write down 5 times 10 powered by 3 or cubic. And then we can have 5 kilogram, since 10 powered by 3 is kilo. And then 0.001 second is equals to 1, and then times 10 powered by -3 second equals 1 millisecond. Try the following. So we have 3 million. So remember just now, when we have 10 powered by 6, how do we write it? Okay. Yes, good. It is 10 powered by 6 or megabyte. If we are using this capacity when we have the computer for storage. But in this case, we are talking about mega in physics. The next example, 0.000000019. We can see how many digits, okay, remember, how many digits after comma. Okay, we do not only count the 0, but the whole digit after comma. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 10 powered by -9. So we have 19 nanosecond. Okay, next example 15. This one, still remember what is this, guys? Yes, good. Microjoule. Yeah, joule. Okay, so we have 15 micro just now. Good. It is powered by -9 joule. So we can call it, what is that? 0.000015. Again, we have to see there are 6 digits after comma. Okay, then got wrong, everyone, because you also have to count the 15, not only the 0. The last, 6 gigameter. Still remember, guys, what is giga? Okay, that's good. 10 powered by 9. Good. Okay, so how many 0 are there? Yes, great. There are 9 0. Let's see. Is that true? 9 0? Yes, that's good. So if you give a separator between every 3 zeros, 3 digits, then you will be able to count it easily. Okay. Next, let's see the worked example. Express 30 kilometer, okay, per hour. Yeah, because this one -1, that means per hour. Okay, in SI units. So what is the solution? The SI unit of speed is meter per second. Yeah, per second means S powered by -1. So recall that 1 kilometer equals to 1,000 meter, and 1 hour equals 60 times 60 second, or 3,600 second. So 1 kilometer per hour is, yeah, let's count. Can you count it? Yes, good. So we counted 1 kilometer, we changed to 1,000 meter because we have to change, or convert kilometer to meter, and then the hour to second, because we are going to have it in SI units, and kilometer per hour is not SI unit. So 1000 meter divided by 3600 second. What do we have? Yes, good job. 30 times 1000 divided by 3600. So we get through. Good. 8.3 meter per second. I believe you know how to count it because the downwards 60 times 60, that is 3600. Okay, so that means you can also divide by the 30. So you got 12 downwards, and then 1000 divided by 12, you got 8.3. Okay, and then you can cross out the 0 and 0. Okay, so the top you only have like 10 and then 300. Okay, and so on. Next example, express A 50 cubic centimeter in cubic meter, and then B 50 meter or cubic meter in cubic centimeter. So write your answer in standard form. Solution. 1 cubic centimeter is 1 centimeter times 1 centimeter times 1 centimeter. I believe you have known about that. Okay, so 1 centimeter equals to 1 divided by 100, or 1 per 100 meter. So if we are counting about 1 cubic centimeter, as we know, 1 centimeter is 1 per 100. So we can write down all 1 per 100, 1 per 100, and then also 1 per 100 meter. So what do we have? Yes, we have 1 per time, because you see 100, 20, 100 again, 20, and 100 again, 20. So we have 6 0. So 10 powered by 6 cubic meter. That's good. Yeah. So when we have 50 cubic centimeter, so we have 50 times, as you see, so that means 1 cubic centimeter, we have to write down the 1 per, okay, 10 powered by 6 cubic meter. So what do I have? Yes, good job. 5 times 10 powered by minus 5. You see, the 0 from the 50, you have to exchange or count, cross it out with the 10 powered by 6. So you got 5. After that, because it is from down going up, it becomes minus 5 cubic meter. I hope you understand about that. Okay, next solution. Continue. 1 cubic meter equals 1 meter times 1 meter times 1 meter. What about the meter to centimeter? 1 meter equals to 100 centimeter. So we have 1 cubic meter equals to, yes, good job. So 100 centimeter times 100 centimeter times 100 centimeter equals to 10 powered by 6 cubic centimeter. So we have 50 cubic centimeter. So we have 50 times 10 powered by 6 cubic centimeter, and then we have 5 times 10. Yes, good. 0 added to another 6. So we have 10 powered by 7. Good job. So next question. The human hair is about 20 micrometer in diameter. So what is the standard form of the radius in its SI unit? Let's see, this is a circle. The radius is, what is that? Good. Because the diameter is 20, so the radius, good job. You have to divide the diameter by 2, so you get 20 divided by 2, you get 10 micrometer.